Given f of x equals x to the third minus 3x squared plus 4x and the critical point x equals 1, use the second derivative test to determine the type of relative extrema at x equals 1. Well, this is how the second derivative test works, right? Second derivative gives you concavity. So if second derivative is a positive number, that means it's concave up, which means at whatever point you're talking about, you're going to have yourself a relative minimum. Okay, if you take the second derivative and your number is negative at that point, you're going to have something that's concave down, which means that point is going to be a relative maximum. If it's equal to 0, I'm sorry, you've got nothing. Okay, you've got yourself a good old inflection point. Okay, because it's neither. Okay, so what we have to do is we have to take the second derivative. So f prime of x is going to involve us using the first derivative. So that's power rule once and power rule twice and power rule 3 times. F double prime of x is going to be 6x minus 6. Now what I do is I take my point, right, x equals 1, and I plug that into f double prime of x. So 6 times 1 minus 6 is 6 minus 6. It's 0. It's an inflection point. Oh, duped. We got duped. But that's how you do it. Given f of x equals 3 over x squared plus 4x and the critical point x equals negative 2, use the second derivative test to determine the type of relative extrema at x equals negative 2. Well, what I know about the second derivative is that if it's positive, right, it's concave up. So at some point c, right, if I plug it in, that's going to give me a relative minimum. If I have something that's negative, it's concave down, which means at some point c, it's going to be a maximum. If my second derivative is 0, well, that's an inflection point. It's neither of them. So let's take a look at this guy, and let me rewrite it out in a much friendlier way so I could just do power rule. I'm going to turn 3 over x squared into 3x to the negative 2, and then add 4x, and then take the derivative of that guy. So f double prime, a regular prime rather, of x is going to be negative 6x to the negative third plus 4. F double prime of x is going to be negative 6 times negative 3, which is positive 18. That was a close one. Positive 18, x to the negative 4 plus nothing. So if I care about negative 2, then let me rewrite this out. F double prime of x equals 18 over x to the fourth. Plugging in negative 2 is going to be 18 over negative 2 to the fourth, which is going to be 18 over negative 2 times negative 2 times negative 2 times negative 2, which is 16, which is going to be a positive number. So since it's positive number, we have something that's concave up, which means it's going to be a relative minimum. Second derivative test, so much fun. If f prime of 8 equals 0 and f double prime of 8 equals 3, which of the following must always be true? Well, f single prime of 8 means that x equals 8 is a critical point. Okay, f double prime of 8 being positive means that my second derivative being positive is it's concave up. And it's concave up at a critical point, which means that's a relative maximum or minimum. So in this case, what I have is I have a relative minimum at x equals 8. Quick and painless. Given f of x equals x to the third minus 6x squared plus 9x, determine all relative extrema. Well, this section uses the second derivative test. So what I want to do is I want to find all critical points, okay, and we'll call them C. For any critical point C, If f double prime of c is positive, that means it's concave up and I have myself a relative minimum. If f double prime is negative, that means I'm concave down and I have myself a relative maximum. All right, so let's take the first derivative and find out my critical points. So f prime of x is going to be 3x squared minus 12x plus 9. Let's set it equal to 0 and pull out a 3, and that's going to be x squared minus 4x plus 3. Factoring this further, I have 3 times x minus 3, x minus 1. So my critical points exist at 3 and 1. Those are my critical points. I'm going to take those guys, and I'm going to plug them into the second derivative, which I haven't found yet. So if the first derivative is 3x squared minus 12x plus 9, the second derivative is going to be 6x minus 12. So f double prime of, let's go in order, of 1 is going to be 6 times 1 minus 12, which is 6 minus 12, which is negative. If it's negative, that means I have, at 1, a relative max. F double prime of, what's the other one, 3, is going to be 6 times 3 minus 12, which is 18 minus 12, which is positive. So at 3, since it's positive, I have a relative minimum. So determine all relative extrema at x equals 1 and 3. Kind of a lazy answer. But these are the specific relative extrema, so I kind of took it a step further, even though technically I could have stopped right there. But I'm happy with what I did. I'm keeping it. Can't stop me. Given f of x equals 2x to the fourth minus 2x cubed plus 6x, determine all relative extrema. We are using the second derivative test for this. So this is what we have to do. Step 1 is we have to find all of our critical points. Okay, so any critical point we'll call C. Step 2 is once we have that, we throw that into the second derivative. If it's positive, that means it's concave up, and at that C, we have ourselves a relative minimum. If we plug in that C, which represents a relative maximum or a minimum, and it's negative, that means it's concave down. And at that moment, we have a relative maximum. So what we have to do is we have to find the first derivative first. So f prime of x equals 2 times, actually it's going to be 8, sorry, 8 x to the third minus 24 x squared plus nothing. Let's set that equal to 0 to find our critical points. Let's factor out an 8x squared, and that leaves me with x minus 3. Okay. Now, multiplicity of 2 scares me a little bit, but I still get x equals 0, and I get x equals 3. Now, what I haven't figured out yet is what f double prime is. So f double prime of x is going to be 24x cubed minus 48x. And with that scaring me a little bit, with that multiplicity of 2 scaring me a little bit, that's going to remind me that f double prime of c, if it equals 0, is going to be an inflection point. Okay, so neither of that. Neither of that. But we'll see if we have to worry about that. We might. So I have 0 and 3. So f double prime of 0 is going to be 24 times 0 cubed. Remember a second ago how I said that we'll see if we have to worry about it? Well, guess what we just got? We just got an inflection point, which is not a type of extrema. So 0 ain't it. F double prime of 3 is going to be 24 times 3 cubed minus 48 times 3. That's going to be 24 times 9 minus 48 times 3, which is going to be, I don't know, 200 something minus like 100 something. So based off of that information, I'm just going to say it's positive because it is. So f double prime of 3 being positive tells us that we have a relative minimum at 3. So the relative min is going to exist at x equals 3. That's how you do it.